Welcome to Flammable and Combustible Safety Training. Today we will talk about material properties of flammables, how to identify flammable and combustible liquids, safe storage considerations, how to control ignition sources, health hazards associated with flammables, and spill response in case of a spill. Did you know you can put a match out in gasoline? This is because liquids don't burn. Vapors burn. It is important to consider the behavior of the vapor. If the vapors are lighter or heavier than air determines if they will rise to the ceiling or collect at ground level. The larger the surface area, the more vapors generated, which means a larger area is in the ignitable range. Even a small spill from a 5-gallon container can cover a significant area. This means that a relatively minor spill can potentially be hazardous. 3 things are necessary for a fire to occur. We need a source of ignition, oxygen, and fuel. Oxygen, heat, and fuel are frequently referred to as the fire triangle. Add in the 4th element, the chemical reaction, and you have a fire tetrahedron. The important thing to remember is that if you take away any of these 4 things, the fire will be extinguished. Now we will move on to significant material properties. Here are a few terms keep in mind. Auto-ignition temperature is the temperature where the liquid is going to ignite without an additional ignition source. I can't think of any of our products where this would be a significant concern. Boiling point is the temperature of a liquid at atmospheric pressure where boiling occurs. The difference between a liquid and a gas in the boiler point: liquids have boiling points above ambient temperature, while gases have boiling points below ambient temperatures. Flash point is an important term. The flash point is the temperature of a liquid where it generates sufficient vapor to sustain combustion. The flash point is an important safety measure, as substances with lower flash points are more volatile and can ignite more easily. The term ignition energy refers to the amount of energy required to initiate combustion or ignite a substance. This energy can come from various sources, such as sparks, flames, or hot surfaces. Different substances require different levels of ignition energy to ignite. For each flammable substance there is a level of concentration in air, usually expressed as a % by volume. The lower explosive limit is the minimum concentration at which a material will ignite. Below the LEL the mixture is too lean and will not support combustion. LEL stands for lower explosive limit. The concentration between the lower explosive limit and the upper explosive limit is the flammable range. We want to try to stay out of the flammable range because this is the range at which there's enough vapor to start a fire and keep it going. The upper explosive limit, or UEL, is where the mixture is too rich and there is not enough air to burn. Above the UEL, the mixture is too concentrated for combustion to take place. Vapor density is used to determine if the vapor will be heavier or lighter than air. Materials with a vapor density above 1 are heavier than air, while materials with vapor densities less than 1 are lighter than air. Now we will look at how to identify flammable and combustible liquids. The DOT and EPA define a liquid with a flash point of 140 degrees Fahrenheit or less and which will sustain combustion. OSHA defines a liquid as flammable with a flash point of 100 degrees Fahrenheit or less. The EPA doesn't regulate or recognize combustible liquids. OSHA breaks combustible liquids into Class 2, which have a flash point between 100 to 140 degrees Fahrenheit, and Class 3, which have a flash point between 140 to 200 degrees Fahrenheit. A combustible liquid that's heated to within 10 degrees should be treated as a flammable liquid. The DOT requires all containers of flammable liquid that are being transported must be labeled with the red label. This can be deceptive because when the product is in the warehouse, then OSHA regulations apply, and not DOT. The DOT only regulates combustibles when they are in containers of 119 gallons or greater. Let's move on to properties of flammable liquids. When a liquid is at or above its flash point, it's going to be generating enough vapor to ignite and continue burning. If there's a leak, it should be assumed that the vapors are going to reach an ignition source. When this happens, the flame can run back along the vapor path to the container. In other words, try not to set up drums of chemical next to things like hot water heaters. Don't put chemical right in front of the burner on a boiler. When a flammable liquid is spilled, it begins to generate flammable vapors which form a vapor cloud. The lower the flash point, the more flammable vapors are generated, resulting in a vapor cloud which extends farther beyond the original source of the spill than a material with a higher flash point. As the vapor cloud expands, it dilutes, going from being too rich through the flammable range until it is too lean to ignite. Let's talk a little about vapor density. If a product's vapor density is less than 1, the vapors will rise to the ceiling. Hydrogen is less than 1, so that will accumulate up at the ceiling. Ammonia is also going to be up at the ceiling. So if there's a leak and you are in an ammonia engine room, get on the floor and crawl out on your hands and knees. If a product's vapor density is greater than 1, it will sink to the floor. It will act like a liquid filling the low points. I can't think of anything that we would be dealing with where we would have to be aware of this. Next, we will look at things to consider when storing flammable liquids. Flammable liquids should be stored in areas that are constructed for flammable liquids. Fire doors are one way to help keep an area safe. If a fire occurs, these overhead doors immediately close and isolate the chemicals or fuel source. Do not prop these doors open and keep the area clear. This is an example of a fireproof door at one of our chemical suppliers. OSHA states that flammables cannot be stored within 3 feet of a building's support beams. The top of the drums and storage must be kept at least 18 inches below a fire sprinkler. This is important when the products are being warehoused and pallets are stacked up to the ceiling. Lastly, adequate aisle space for inspection and to safely operate a forklift must be provided. Understanding how to control ignition sources will help improve safety. Some common sources of ignition are open flame devices, hot work, tools and equipment, including forklifts, hand-operated tools and static discharge. When transferring flammable liquids from one container to another, such as from drum to drum or tank to drum, the motion of the liquid inside of the pipes and hoses can generate static electricity. You can control and prevent static discharge by grounding the container. Here's a picture of an insulated fire-safe container. Containers made of electrical insulators, such as glass, plastic or fiberglass, cannot be bonded, so only metal containers are used to store flammable liquids. Spontaneous combustion can occur when you have rags soaked in a flammable or combustible liquid. The oxygen in the air combines with the liquid and generates heat. Eventually, this can get hot enough to ignite the rag. Don't just toss rags soaked in combustible liquids into the garbage, or you are asking for trouble. If you clean something with a rag, rinse that rag out. Make sure there's no residue in the rag before you dispose of it. And if it contains flammable liquids, dispose of them in the special, red oily waste cans, at customer sites. When these cans are full, a service will pick up and haul away the flammable stuff. Let's talk about health hazards. Nearly all flammable liquids are organic, or carbon-based compounds. Most of the flammable liquids we handle are designed to be solvents, that is, they are designed to dissolve organic material. In many ways, they are like the molecules that make up your body, and as such they can interact with your body in a variety of ways. Individual sensitivity and susceptibility to solvents range widely from person to person. Some people may be seriously affected by concentrations that seem to have no effect on fellow workers with the same exposure. Breathing vapors from solvents can have a variety of effects, ranging from a fairly simple intoxication to long-term effects like cancer. The effects of exposure to solvent vapors depends in part on the concentration, length of exposure, and the individual person. Rarely are we around the vapors long enough to worry. Some acute effects you might experience after short-term exposure, usually to a high concentration, are dizziness, nausea, or feeling a little drowsy. First aid for exposure to a high concentration of solvent vapors is to get the person into fresh air and administer oxygen. Some serious chronic effects may show up for those who have had long-term exposure. However, we really shouldn't have to worry about this, because we're not around these products for a long enough period. Long-term exposure effects can include cancer, liver and kidney damage as well as on the immune system. Other side effects can include insomnia, mood swings or chronic depression, but again, this is more for those who have long-term exposure. Skin contact is one of the most common problems resulting from using solvents. You are not going to experience a burn, it is going to be more like a rash or dermatitis. It is going to make your skin very dry because of its ability to dissolve the fats and oils. Removing fats and oils will also make your skin more vulnerable to infection. The best thing to do is to wear the proper PPE to avoid getting these products on your clothing and skin. Organic liquids in the eyes will cause some pain, but it's not anywhere near as potentially damaging as acids or caustic. If you get anything in your eyes, rinse them for 15 minutes and then seek medical attention. You only have one set of eyes, so it is better to exercise extra caution. Now we will go over what to do in case of a spill. For large spills, eliminate all open flames. Don't operate any switches, even to turn something off. Leave the area and advise your supervisor. If possible, increase natural ventilation by opening doors and windows. Air-driven fans are acceptable. Use a combustible gas detector when entering an area where flammable liquids have been spilled. Do not enter if the meter indicates more than 10% of the LEL. Maintain ventilation. If no meter is available, do not enter. It is only safe to enter when the concentration in the air is measured to determine that you don't need respiratory protection. Our drivers are the only ones who are fit tested for respirators. No one else is permitted to go in any area where you're going to need a respirator. If you spill, use booms or absorbent socks for cleanup. Refer to your spill standard operating procedures. And remember, if it's flammable, it must be disposed of in a specific flammable approved container. When it is safe to enter, turn the container so that the leaking spot is above the liquid. If you have a leak on the bottom, turn the drum on its side. Use floor dry to absorb the spill. Place the saturated floor dry sock into a metal drum and label the drum as hazardous waste. Here are some examples of flammables. So, we went through a lot today. It is important to read safety data sheets. Read labels. Adequate ventilation's the best way to make sure you don't have problems in your facilities. And what's the best way to stay safe? Don't get the stuff on you. Wear your PPE. Keep it clean. Make sure it's in good condition. If it needs to be replaced, reach out to customer service. They will immediately get you the proper stuff to work safe. And please remember, you must return to the Training Today platform and take the short quiz to complete this course.